Hello everyone. Today I will be discussing free will. I will try to make this discussion all-encompassing, but really it is a response to Michael Leibovitz video on his YouTube channel Rational Egoist, which was titled, I think, A Case Against Determinism, following the name of the book of one of his guests. So this video I'll probably title the case for determinism. Okay, but I will cover, I think, all positions and just give a general idea what do we know about this topic and what are the possible thoughts. Okay, so let me probably share a screen of the tablet because I'm gonna draw pictures and write something. Yeah, so first of all, where do we start? I guess I'll need to start with some metaphysical position, right? My view on this topic is really materialistic. Of course, that's already a big choice, yeah, to make. There are so many alternatives here proposed by different philosophers, but for me, there is a material world, and human bodies are part of it, and we have developed complex brains, which could acquire information from about external world from all our senses to integrate into this picture. And this is how our consciousness works. This is what our consciousness is. It's our faculty of awareness about the external world. But it at the same time we are part of the material world, and therefore consciousness has to be somehow explained or derived from the physical phenomena. In other words, for any our subjective experience, like I don't know, the seeing colors or something like this, there is some corresponding phenomena in the material world. So I could depict it in such diagram. Here on this side, we have a material world, and here we have consciousness. So here we'll have some physical phenomena, and it gives rise to subjective experience. Yeah. Now, well, what we should say about it? Really, the free will, which is the topic of this discussion, by default, kind of lives here, right? It's our subjective experience, right? We are aware of possibility of our choices, and in fact, we use this subjective experience to do everything in our life, right? Including performing physical experiments, right? And today I want to discuss what physical phenomena corresponds to it, right? What stands here? My point is that could be quite non-trivial, and people's naive first guess might be just wrong. Let me give you a simple example what I'm talking about. Consider another case. Imagine here we have a spoon in the glass of water. And when we see it by our eyes, if we use just our eyes, it will appear, broken, right? Look like this. That's approximately the image. Of course, if we don't think too much, we could try to interpret this as, a broken spoon. Right? It seems like that's what future stands for. But if we really use our reason, or if we also maybe use just our fingers, additional, to gain maybe additional sense data, we will really see that that's not what's happening here, right? That this is not the physical phenomena which this image stands for. So yeah, the question becomes, yeah, aren't people doing the same thing with the subjective experience of free will? Now we need to introduce more definitions. So as you could probably guess now, different people have different opinions about this side of the story. Now the position which most people held by default is free will, which is satisfying the following two criteria. Now usually, let me write. So yeah, what they mean by free will as a certain physical phenomenon, right? Of course, if we want to distinguish the physical phenomenon from subjective experience, we have to say it, which giving rise. Yeah, that satisfies two conditions. So the first condition, which may be the main topic of today's discussion, is indeterminism. So in other words, people could call it also true alternative. the existence of true alternative or metaphysical choice, or even simpler, the ability to do otherwise. More concretely, as you follow from the name, indeterminism is rejection of determinism. So now let me state what determinism is. Determinism is a hypothesis, you could say, about our universe. The future state of the universe is uniquely determined by the past state, prior state. Well, okay, I don't know. I use the term state, which might require some clarification, right? I don't think it's well, that unusual or unjustified or that far from human intuition. Um, Let me state here in this part of discussion simply, like, imagine at a given moment of time, yeah, let's see, my arm could be somewhere, right? This position of my arm is its state, right? At the next moment of time, the state of my arm could change. It could be somewhere else. So that's what intuitively state means. I feel like if you agree with the notion of time and you agree with the existence of moments of time, you could grasp the notion of a state of a system. Now, some people could say that, well, we don't quite agree on the existence of time, right? Are you secretly using some kind of Einstein general relativity theory to even have it? There could be theories without time at all, just with relative motion. Then how would you even define it? Is this definition model dependent? Then I would say yes. So I'll discuss it in more details further. Indeed, I have to rely on some knowledge about the universe to even say something like this. It's true, some of our current knowledge could be inaccurate, but I could not argue for anything from the position of ignorance. So I assume the current knowledge to be true. Yeah, it's fair to say, for the sake of the argument. And I'll discuss this a little bit more in the main part. Here, I just hope that you will at least intuitively understand what the state of the universe mean. Okay, so that's condition number one. But usually that's not what people want, not just indeterminism, right? They want condition number two, volition. Which also probably in this free will literature is known as agent causation. Or self-causation, maybe. In other words, applied to the situation that actions of conscious agent are caused by the conscious agent itself. Um, this view is literally, I would say, just the application of the most general view of causality to this particular case. If we pick the general view of causality, which is entities act in accordance with the nature, we could then say that for certain entities, it's in their nature to cause their own actions. Like for example, I know with a stone lying on the ground, we know like it will start moving if you hit it with your leg or something like this. And for a living organism, it's not like this, right? The living organism actions are caused by the organism itself. So that's kind of what the attempt here is. Okay, so I hope I explained this part. Now, let me state for the sake of terminology that in order to avoid confusion with free will as a subjective experience, which is undeniable, and this particular view of free will, we need to introduce special terminology. And the terminology for this is called libertarian free will. So free will as a physical phenomenon, satisfying 1 and 2 is called libertarian free will. Yeah, I don't know where this terminology comes from, but I realized when I was looking through AI responses about the literature that it's kind of universal. So I will use this. I don't mind it. Now it's also interesting to notice that I personally want to introduce another term, which is not standard and is not usually used in the literature, but I think it's correct. So the free will, which satisfies only condition 1, the view of free will, I would call Epicurean free will. In the name of ancient Greece philosopher Epicurus, who was really the first one to introduce this notion and to help, as far as I know, to help this view on free will. He made a prediction that the laws of mechanics might be indeterministic, that there could exist fundamental probabilities, and this means those probabilities allow actual, alternatives. So yeah, he called it Epicurean swirls, I think, this moment of indeterminism in the motion of elementary particles, atoms, right? As Greeks already anticipated the discovery of atoms through their complicated reasonings. And Epicurean was in favor of the hypothesis, but he also predicted that the behavior will not be deterministic. So in some sense, you could say he anticipated the discovery of quantum mechanics, which is kind of curious in its own way. However, yeah, that's not really the free will not really free will, right? It's not what people really want from it, because then your actions are not really caused by you. They really kind of, in the end, reduces to some random choices, some random effects. Okay, yeah, so this view is kind of popular today precisely because the most popular and well accepted, let's say, interpretation of quantum mechanics is probabilistic, so indeterministic. But I want to notice here, which is very important, that not all interpretations of quantum mechanics are probabilistic. For example, de Broglie-Bohm interpretation. Yeah, let me write here. Yeah, so the Broglie-Bohm interpretation is not probabilistic. It's also known as pilot wave interpretation. It's not really fully developed, and a quantum field theory analogs of this pilot wave are not built yet, but it's probably possible. So the people who might held determinism dearly, they have some room for it, even with today quantum mechanical experiments. So now, yeah, the last definition I would say is that free will which doesn't satisfy one and two, I call determinism compatible. Well, sometimes Epicurean free will is part of the compatible definition. So it's really only like libertarian free will or different form, some various form of compatibilist free will. Either Epicurean one, if you think that probabilities are fundamental, or deterministic one, if you don't think they are. Okay, so I will really discuss this last option or the last two option, and I will try to show what the problem with libertarian free will can be in terms of the laws of physics, and well, can we actually reconcile laws of physics with libertarian free will, and where could we find a room for it? But at first, yeah, I will make a case for determinism compatible free will. And for that, I need to make a case for determinism itself. Yeah, so the next part I'll call case for determinism. Now, well, really, determinism, at least how I know it, is a result of induction from experimental data, right? Mm. As you probably know, the rules of induction are not fully worked out. Therefore we can't really know which induction is perfectly valid and which induction is not. Therefore we need to be extra careful here, and therefore I would expect some people disagreeing with steps here and still being objective, right? Still, I would say, hold a valid scientific opinion. Okay, so but here's one rule of induction which I'm gonna use for sure. Rule of induction number one. As you could see, if you're trying to build a theory of induction, we could do it like in math, using induction itself. Imagine we already established some general rule using induction from the particulars. We don't know how, because that's hard. But here's what we can say. And general rule, which was established by induction, can only be abolished if new evidence is found which contradicts it, right? And in fact, it should be abolished in this case. Actually, even must. So really, this is the only clear boundary, clear restrictions on induction is the existence of contradictions. Okay, so therefore, before I'll go into details of how exactly I will induce determinism, let me first check that there is no contradiction with our immediate subjective experience of free will. I think, it's not that hard. I think even a lot of proponents of free will agrees that their subjective experience of free will doesn't provide immediate contradiction with determinism. And here's how you could see it. So first of all, what could be the evidence against determinism? The immediate option which comes to mind is that we can always imagine making the opposite choice. For any action we take, we can always envision doing something else, right? But that doesn't imply that this otherwise was actually possible. We could imagine all sorts of things which don't actually exist. Yeah, so that's point number one, right? That's not really a contradiction. Yeah, the related one is that we perceive our choices as free, right? But what does it mean? Imagine you took some action and some other person inquired you about the reasons for your choice. What are you gonna do? You will state those reasons. You will state the reasons which have actually determined your choice. And those reasons, well, they come from your brain, right? Which come from all the previous results of analysis done in your brain, which come from all your previous experiences. And that's one option. Another option you could say is that, well, I really made the choice randomly. I didn't care about this decision at all, so I just picked randomly. Or you could say that, well, there were certain probabilities, of this being the right choice and that being the right choice. And these probabilities were kind of determined by my prior knowledge, and then I pick randomly among them. So none of those options really contradict either Epicurean free will or determinist compatible free will. At least, if you, at least Epicurean free will fits them, right? In fact, determinist free will fits them as well, because the probabilities which you're talking about might not be metaphysical, right? They might not be fundamental. So naively, at least on the first glance, there's no contradiction. Now I'm aware of a more sophisticated arguments against determinism, which I learned when I first time heard from Onkar Gate, but also from other objectivists, my friends who explained this argument kind of better to me. It's an argument about impossibility of knowledge. So if the current state of the universe is fully determined by the initial state, this means the person condition and everything he knows was kind of predetermined, right? So in other words, if two people have an argument, one of them is predetermined to be right and the other one is predetermined to be wrong. And the argument says that, well, how could you know that you're not the one being wrong? Like, what is the mechanism now for establishing certainty if you don't have actual choice? Well, I mean, I don't know, first of all, whether I stated the argument fully correctly. But the general idea is that your knowledge relies on the existence of these actual choices. Otherwise, it seems like, like your knowledge is kind of tautological or something, right? It's almost like like the entropy laws. The entropy of a concrete state is always zero. So yeah, I mean, I don't know, but it's just my analogy. What could be the answer to this argument? The answer is that yes, I concede fully that well, in this discussion between those two people, one of them is predetermined to be wrong, and now one of them is predetermined to be right. And yeah, you have no really control over it. But the impossibility of knowledge actually has nothing to do with choice. Um, you could imagine, any, robot or any, entity following some algorithms. And if the algorithms are designed for it to acquire knowledge about reality without even its choice, to the extent it's possible, well, it will overall seek truth. And yeah, my point is that human bodies are examples of such entities. It's true that our bodies are really evolved to sustain our life, and our complex brains evolved for the same reason. And we know that truth about reality is what helps to sustain our life. And indeed, it's part of the function of the brain is to seek truth. Of course, it could make mistakes and it could be wrong, but it has the mechanisms to correct those mistakes unless this brain is really dysfunctional. So, in other words, yeah, you could ask them, well, how do you know all this? How do you know that your brain is not dysfunctional, and so on? And that's really, at its core, the standard skeptics argument. Skeptics just usually state that, well, your knowledge is not really possible because you could never prove the validity of your reasons or your senses, because you rely on them to prove even that. Um, and I agree, but I want to point out that the skeptics argument um, really work work equally well against the entity which has libertarian free will, because even proponents of free will agree that free will doesn't determine everything in the world. And skeptics could always say, well, what if the universe conspired against you in such a way that all the choices are wrong? Yes, you could have choice, but how does it matter? um, in other words, the skeptics' arguments were always arbitrary. This means they really could start from any place. They kind of look like this. You have nothing, and then implication, um, skepticism. I don't know how to spell it. So, in other words, you could write anything before it. Could add here determinism. And it will look like there is a logical connection, but actually is not. So in other words, if the proponents of free will dismiss skeptics' arguments as arbitrary, the determinists could do the same. Okay. Now I think I tried to address as much as I could the kind of immediate contradictions of determinism with our subjective experience. And I could start, building the case for determinism. Because, well, how do we know that this claim is not arbitrary, right? Where does this come from? Yeah, so the next part will be called, induction process. For determinism. Okay, so I would say the modern view of determinism starts with the same place where science started. Like it's not the same. Well, again, I'll talk about separately. But the justification, the real justification, started with emergence of science, and whatever views existed before, there was no proper justification, right? And you could see it already in really tabletop experiments. First, with inanimate nature. So really, I'm talking about like Galileo Galilei and Newton. Um, it seems like, well, you have an inclined plane, and you have some sort of cylinder um, on it. Rolling down this plane, and then maybe you ask it to, to reach a certain height here or something, or there's like some metallic balls on the plane, and you give them certain velocities and which have certain masses, and then they collide, and they fly apart. And of course, these experiments were concerned with some, complicated questions, but the first things which we observe and which is important is that the outcome of the experiment was uniquely determined by the initial conditions. So yeah, if we try to take different masses and accelerate them to different velocities, the outcome changed somehow. And that's what people were studying. But the first and most important step is that um, if you keep conditions the same, the result is the same. So yeah, that's how we induce things like Newton's third law from this type of experiments. Newton's three laws plus the laws of gravity. Yeah, so I want to say here that this is kind of, yeah, what the justification was and where it comes from. So it really comes from this inductive methods. And I agree there might be some, the guy in ancient Greece who was sitting on his agora and picking his nose, some kind of great philosopher who just, made this up. Like he was pretending that he studying the world, but actually just producing these fairy tales like, oh, God must exist and everything is God's will, so everything has to be determined. And then this determines really just this quasi-religious view, which just happened to become so influential that it kind of spread to all the scientists, and really they could only analyze the experiments through this kind of prism of this broken philosophy, and that's why all interpretations of experiments already, the have this philosophy imposed on them. But really, it's kind of not yet. Another view is that, well, it's more like a Kantian view, right? Where that the true reality is really unknowable, and what we are building here is just kind of the model, which is like wrapped by or influenced somehow by the way our consciousness works itself. So really, the true universe might not have the determinism. It's just our mind orders things, whatever things it sees, tries to order. So mm, yeah, first of all, about the model, I tried to address this before. Like, what I'm trying to tell me is that the fact that the cylinder who is getting released from the same height ends up at the same place is this just a model. So this is not really part of reality. And of course, I can, maybe agree that our current understanding is wrong, and reality is not as simple and something like this. But I can't argue for anything from this position of ignorance, right? Like, what can I say about humans' free will from the fact that maybe uh, my understanding of the laws of nature is just models of the real one. Yeah, and of course, here we talked about the laws of nature, which is deterministic in the tabletop experiments, but it carried on further, right? We still have, after this, experiments with magnets and wires and electric currents, charges, and this led to Maxwell's equations. Which are also deterministic. And eventually, we are going to lower and lower scales. Yeah, we're probing smaller and smaller sizes, and we discovered atoms, right? So that's what well, ancient Greeks anticipated, and here we really the first time see some potential contradiction with determinism. That's where quantum mechanics was discovered as well, right? Yeah, as you could see, it's not really dogmatic position. There were experiments which made us think that the laws of nature exist and the nature is deterministic. And I consider them to be really the triumph of inductive methods, science, and human mind. Because the default position is that the universe is chaotic, right? And we could not study it. So that's actually a big progress. Determinism is a big progress. So this was like a big hit for many people, that in quantum mechanics, it seems like we could never avoid this probabilities. that there is something which you just can't know. And yeah, in fact, even if you try to reject the probabilistic interpretation, you still end up with the hidden variables theories, which one of which I stated is the Broglie-Bohm palette wave interpretation. It's a hidden variable theory, and these hidden variables we, at least for now, can't detect. So yeah, I would say it's like a downside for us. But even if we assume this probabilistic interpretation of quantum mechanics, what it will imply for the free will is this Epicurean picture, right? Not quite what proponents of libertarian free will want. Okay, so far we are going down in scales, starting from the tabletop experiments and making sure that the nature is deterministic there, and then going to atoms and seeing that, well, up to these questions of whether we know the evolution of all of the observables or the evolution of some probability distributions governing the observables, whether the universe is still deterministic or not. Like we see that, yeah, it goes kind of more difficult, but we induced those general laws. Now I want to start going up and see, could we really use these laws which we discovered about elementary particles to learn something about more complicated objects. Yeah, so we want to establish the scope of validity of laws of nature for fundamental particles. Let me just start with the simple things. Of course, I didn't actually talk much about what kind of particles I have in mind. And, we now went beyond atoms. We now know that atoms are made of nucleus and electrons, and nucleus are made of protons and neutrons, and protons and neutrons potentially made of quarks. However, this story is a bit complicated. But this is kind of general discussion. Suppose that we have some particles which are fundamental, and then we start building something out of them. What we could say about the things which we build out of them based on, our knowledge of the nature of those particles, laws governing them. So if n is the number of particles involved, what we could do, surprise, surprise, we could only solve exactly n equals 2 case when n equals to 1, right? This is trivial. Let's solve exactly. And n equals to 3 is called already a famous three-body problem. We cannot solve exactly, and it's hard even numerically. In general. But then the question becomes like, okay, this means that laws of nature basically useless. well, not quite. Uh, they are not quite useless if we have additional simplifying assumptions. So you could say for any n, they work in weakly interacting limit. Also called weakly coupled. So if you have just n particles and they're free, they don't interact with each other, it's like solving the case of one particle. Doesn't matter. If they interact with each other a little bit, we could use, all our strong techniques of perturbation theory and getting some approximate information. And it always works. Like this agrees with experiment. Um, so that's really, I would say, what makes me more certain that there's some laws which fundamentally work always, because the weakly coupled regime is really continuously connected to the strongly coupled one. It just your predictions slowly start to get worse and worse and worse, and eventually you can't calculate anything if the strength of the interaction is too big. But at no exact point you could say this when it breaks down. Okay, now another important case, also any n, but there are some other special simplifying circumstances. For example, from additional experimental influx input, we already know something about solution of this, differential equations that I was describing the laws. For example, we know that atoms in the metal, they form crystal structure. We could see it, right? So yeah, no example. Crystal. We could see how atoms sit at, at a certain position and form this periodic structure. That's how metal look like. But they could fluctuate a little bit around the equilibrium position, like this, in all those directions. And we could study questions like what happens if, other object hit it. The atoms really interact electromagnetically, right? And what it does, it will produces this wave of density. So this atom moved a little bit, it shift the next one, a little bit, and that shift this one. And then if you remove this, external force, they will shift back, they will relax, but the wave will travel through the metal at a big distance. So those waves traveling through metal are described by what's called phonon physics. And they're really weakly interacting. And we could study them, and many important properties of materials, of crystals, could be calculated using this approach. So this is the first time we really arriving at the notion of effective theory. So yeah, this notion is central to the whole story. So I'll give a general definition, and then I will try to illustrate it with some examples. Now, okay, so let me try. So effective theory is a description of the world, right? Of a certain subsystem. Which only works on a certain big enough scales. Certain big enough scales. And in certain special circumstances. Yes, in other words, it works not with fundamental particles, but with some emergent phenomena. Yeah, collective phenomena, collective motion of particle. Or average quantities. In this example, with metal, these waves are the collective motions of many atoms. But the single wave is a new emergent entity. And different waves can maybe scatter, interact with each other, and we study the behavior of these waves. So this is like effective theory of these waves. So as you could see from the definition, effective theories have a certain gradation. They're graded by scale, certain grading. Yeah, so from more fundamental at the low scales, small microscopic scales, to more effective or less fundamental at higher scales. So in other words, as you would know right now, if we start at the most fundamental level, right, our world is described as some kind of quarks plus gluons, right, plus all the photons, electrons, and so on, Higgs fields. So standard model. Then on the next level, we have all these protons and neutrons. They're really composite particles, right? In terms of these fundamental ones. And then this becomes atoms. Atoms are made out of nucleus, which made out of protons and neutrons. And then from atoms we build molecules. And from molecules we build solid bodies. And there could be theories describing solid bodies, like the one we talk about. And then it really goes to cells. For example, if you want to study animate nature, and then multicellular cellular organisms, potentially including humans, and then the society. This is the biggest known level organization of matter. I don't know where further we could go. So yeah, now I need to pause here for a second and discuss this view, because this view by itself is called reductionism. And a certain philosophical position. And this could be questioned already. First of all, I presented here standard model as fundamental, but really nobody believes today that it is truly fundamental, and there are things before it, maybe string theory, maybe something else. And in fact, some people think that fundamental laws of nature don't exist, that there is really no stopping point, and this chain continues forever. Now, that's not the only way reductions could be rejected. That's still kind of agreeing with the existence of this grading. There are people who could just reject the idea of grading and the idea of theories being fundamental or effective. In other words, for whatever system, for whatever level of organization of matter, we just have our own theory, our own laws, which just work, which just explain experiments, and the fact that, you know, really one thing is made out of another, and the laws describing more elementary particle should have something to do with laws describing things which are made out of these particles. That's really not of our concern, or that's kind of irrelevant, or let's say just wrong. So yeah, that's a valid position, because in most of those cases we can't really prove that effective theory can be derived from the more fundamental ones. However, in some cases it was done, and I would say it's an important part of our knowledge, to be able to think about which theory is more fundamental, and can we derive less fundamental ones from more fundamental ones. That shows where the boundaries of effective theories are and what happens when they start to break down. Let me give you some examples. as I promised, right? So the first one is hydrodynamics. Well, you probably know what it is, right? It's a theory of liquids and gases, right? And it really works with densities of liquid or gas, of mass density, right, at a given point, and velocities. Um, yeah, so you have some sort of field of velocities at every point. So the liquid, it flows somewhere, right? But really, we know that liquid is made out of atoms. So this density is what? It's just average number of particles in some small volume of space. And velocity is just average velocity of particles in this small volume of space. Now, in this particular case, the dynamics of this densities and velocities is governed by Navier-Stokes equations, right? And we actually know that they could be derived from the laws governing these elementary particles. And there was a Fields Prize just given for this proof. So this is the case where reductionism worked. Yeah, and the advantage is now we know that if liquid at any point develops some kind of singularity, I don't know, vortex, and the Navier-Stokes equation doesn't work anymore, we know that in reality what happens. Like we know how the more fundamental theory kicks in, and we can always save ourselves. Now, I want to make a further comment about the status of effective theories and the idea of reductionism. So why do we need effective theories? I don't know. I hope it's clear that if we want to study the weather or the dynamics of tornado, we really gonna use Navier-Stokes equations, not the fundamental dynamics of atoms. We would never be able to solve that. So effective theories, of course, simplify our lives. So they're very good, actually, right? They're useful. And the fact that we can't really predict the weather using fundamental particles is what made some people reject reductions outright, because if you can't really make any predictions with your equations, then how you could say that these equations describe what your the phenomenon which you're talking about? Yeah, but as I said, that the problem with this approach is well, it seems like if we follow this path, we would never discover the connection between thermodynamics and mechanics, right? we would still, we wouldn't care about the potential contradictions, the resolution of which led us to further progress, right? What's written on Boltzmann's grave. So I would say, even if each particular instance and phenomenon is described by its own effective theory, it is useful to have in mind that fundamental one exists, or more fundamental one exists. Now, there is one more property of effective theory which I would like to talk about. As you could see in this case, the fundamental description was fully deterministic. It was some equation describing elementary particles. And the Navier-Stokes equations, which are describing as average quantities, are fully deterministic as well. This is, I think, called scale separation, or like a full scale separation. So in other words, if we only ask about these average quantities, like density and velocity, we could still get determinate answers for them. We have enough information to fix the future behavior of density and velocity in terms of initial state, our initial knowledge about them. I want to emphasize that this is not always the case. So if fundamental theory is deterministic, it doesn't mean that the effective theory is deterministic as well, in this kind of effective theory notion. Here I'm using the determinism like not in its metaphysical sense, right? But in terms of what we could actually know, given our current state of knowledge, what we could actually predict. Yeah, so the example number 2. It's called Brownian motion. And this is the motion of small, I don't know, pieces of dust, of some particles inside the liquid. Under the action of molecules of this liquid. So the atoms, molecules of liquid moving around, and they hit this big particle. And this big particle moves somehow. Because of these hits, it tumbles like this, left and right. Let me probably try to show you the video. Okay, so do you see it? So that's how the particle moves. And of course, if we know the positions of all little black molecules, we would know where this big yellow particle in this picture, yellow one, would move, right? Exactly. So the fundamental theory is fully deterministic. But now imagine you want to describe the notion of this big yellow particle not knowing the position of a small molecules of liquid, because they're too small, you can't see them. Of course, you wouldn't be able to know it exactly. However, there's still a way to describe the probability of where this particle will be. So that's really the first example of probabilistic effective theory. Another example is stock market. If you know a stock prices today, you don't know what the stock price will be tomorrow. And just think about it. You actually living on the in this scenario in the highest level organization of matter, the level of society. So in other words, to know the stock prices tomorrow, you'll have to know exactly what's happening in every person's brain and what kind of bet he's is going to make tomorrow, right? Let's say that's impossible. But if you talk about probabilities, it becomes much easier, and this probabilities of stock market prices is really kind of almost like Brownian motion with blows and whistles. Right? Which is kind of fascinating. So why I'm even bringing this up, this scale separation question, because humans are basically will be of this the systems of this type. So humans are certainly large N and strongly coupled, strongly interacting. So of course we would never be able to solve the dynamics of human exactly or even approximately. So we have to come up with some effective theory. And the best description of human behavior which we have is actually would be precisely in terms of the fact that humans have complex brains, and these brains allows them to have long-term memory, and therefore they could develop complex ideas based on all their prior experiences, and these ideas is what guide their actions. So it's kind of similar to stock market example. If you know the ideas of a person, you can't exactly predict his actions, but you could tell something about the likelihoods. Like, well, if you know the person supports some kind of I don't know, a welfare state, he'll probably gonna vote for some kind of labor parties, right? That's kind of how we think about humans. Now, I want to also mention here this position which was discussed in Michael's video about social determinism, which is really, I think, kind of simplification of deterministic ideas. Precisely because of this misunderstanding of how effective theories works. Like, no, we can't say that this average knowledge about human, this crude approximation uniquely determine human action. Um, Precisely because I don't know. Yeah, your brain is very complex, and it's true that your decision could be affected by, you know, uh, by the behavior of some particles with history prior to even entering your own body, right? Like it's not like, knowing like even all prior social experience of a person, we could know exactly what he's going to do. However, yeah, I would say that to big degree, um, the ideas you have been exposed to, um, and the way you've been exposed to them will to big extent determine your life, right? Like what you will do. So it's not like important decisions will be left on on some random choice derived from some microscopic behavior of some particles in your brain, right? It's really all be coherent motion based on all your long-term memory. So it's really more robust. Yeah, okay. So now I want to briefly discuss what would happen if um, we try to push back against determinism and really would like to have a libertarian free will. Mm, how would it look? How would it look like from the perspective um, of the laws of physics? That would really mean that for some a large enough n, the laws of physics has to be violated, and it seems like for no obvious reasons, and most importantly, in a bit unclear way. So imagine you perform a voluntary action. You decided to raise your hand, and you raised it. What was the cause of this action? We'll start from the hand. Well, it moved because of muscle contraction, right? But why muscle contracts? Well, because there's some current running through the nerves in your hand, which make the muscle contract. That's just how muscle works. Where does current come from? Well, it comes from your central nervous system, and that originated in your brain. And well, how this current was generated in your brain? It resulted from the discharge of certain, built up potential inside neurons, different neurons, right? So you have neurons connect to other neurons, right? There is a charge flowing into them. And then when the amount of charge on them reaches a certain threshold, they discharge, right? They create a current in the well uh, into this into the third direction, pushing it for the outward. I don't know, well, to the next neuron, right? That's how this network works. So really, we have a cause for everything here. If you want to have some sort of libertarian free will, that would mean that at some point, some motion of some charged particles, right, was not caused by the actions of other charged particles on them, but it's actually caused by, well, some conscious agent, right? Your consciousness somehow. So in that sense, um, the libertarian free will is not that much better than God's will, because that's how God's will work. Yes, of course, there are laws of physics, but at some point, God couldn't intervene and change them. It could just change the outcome of reality, right? So that's kind of the problem. It's hard to imagine what should be changed in the laws of physics to accommodate for this possibility. Of course, I'm open to something like that. I don't hold, the modern laws of physics dearly. They could be wrong, of course, but I want to have some kind of positive vision. So far, I just don't see any options. Yeah, so that's kind of the general considerations. But in the Michael's video, some experiments aimed to study the free will were also discussed. And I think they were discussed very poorly. And I agree that the experiment neither prove or disprove anything here, but they're quite interesting themselves, and I think they address a lot of misconception that libertarian free will people can have. So I want to talk about them. Yeah, the first one is the one which they discussed, and the most famous one is Benjamin Libet, 1983. So yeah, I think I will just show you maybe just EI results. Well, so yeah, the description of the step. Participants sat comfortably and were asked to perform a simple self-initiated movement, typically a quick flexion, bend, or of the wrist or fingers, at the time of their own choosing, without pre-applying external cues. They were instructed to do this spontaneously whenever the urge arose. The measuring time. They voiced a fast rotating spot on an oscilloscope clock, and after each movement, they reported the exact clock position corresponding to the moment they first became consciously aware of the urge, wish, or intention to move. This is called W time, or will or wish. Simultaneously, EEG recorded brain electrical activity focusing on the readiness potential, a slow negative buildup of voltage over the motor cortex areas that had been discovered earlier. EMG precisely timed the actual muscle activation and movement. Okay, so what was the results? So this readiness potential looked like this. It builds up slowly and then discharges. It's some voltage, as you was explained, across some points in the brain. And it discharges at the onset of actual movement of your hand. And what interesting, it starts to accumulate approximately what, half a second before this movement, and the moment of conscious awareness happens approximately 200 milliseconds before the discharge. So in other words, the interesting observation was that how that the readiness potential is building up for this movement before you become consciously aware of it. Like it seems like your decisions should, predate any action which your brain will take to perform the movement. So yeah, that was the maybe somewhat unexpected result. However, yeah, the Libet himself noticed that within this window, person could still give a command to stop the movement, and then the action doesn't occur. He called it free want. And of course, there's other problems too. It's possible that really this readiness potential just periodically appear in our brain, and some of them reach this awareness level and then become an action, and some of them just die out before that, and really interpretation is not clear. Plus, in my opinion, the way he measured time is just too inaccurate to tell anything on this type of scale of basically 1/3 of a second. Luckily, the experiment was repeated in a way better setup recently. Yeah, let me try to find it. Yeah, so Soon and Hayes 2008 experiment is way more impressive. So in this experiment, they put participant in the MRI scanner, and they were analyzing some, abstract thinking part of the brain, really, not just the motor cortex. They saw a screen with a stream of letters changing rapidly, detected the clock for reporting timing. At any time they choose, they freely pressed either a left or right button with a corresponding hand. There was no external cue telling them when or which one to press. The choice was completely spontaneous. After pressing, they reported the letter that was on the screen at the exact moment they first became consciously aware of the decision, the W time. Then the researchers used multivariate pattern analysis, a form of machine learning, to look for subtle spatial patterns of brain activity across many voxels that could distinguish future left versus future right choices. Using activity, yes, what the results were. Using activity patterns mainly in the frontopolar cortex and the precuneus, I don't know what it is, they could predict which button the person would press with about 60% accuracy, well above the 50% chance level. The prediction was possible up to 7-10 seconds before the participant reported becoming consciously aware of the decision. Important, this predictive signal appeared in the high-level association areas, not in the motor cortex. The motor cortex signals appeared much later, closer to the actual button press. Okay, so that's kind of very impressive, right? Because now the time is significantly longer, so there's no room for mistake, and there's still noticeable predictive power. So it kind of raises a question what libertarian free will can actually even mean. Certainly, if some people thought that this means that if you are willing to make a truly random choice, you will be able to do it. It's actually not true. So now, if you are trying to perform a random choice, well, AI could already tell, analyzing the activity in your brain before 7-10 seconds before you become consciously aware of your decision, what you're going to choose with 60% probability, which is quite impressive, I would say. Yeah, so that just kind of adds to this question that libertarian free will is a bit hard to imagine. Okay, so that's really what I wanted to say about free will directly. But there are actually also some things I want to cover about the notion of self-causation. And yeah, the definition of life. Yeah, that's why it's important. Remember, I said that the idea of free will in this, libertarian free will actually comes from this agent causation or self-causation, which is just derived from the most general definition of causality, right? Definition of causation. And that's really built on Ayn Rand's definition of life. So my friend Objectivist told me this. So apparently it has nothing to do directly with free will. The self-causation is just what Ayn Rand attributed to all living organisms. And simple living organisms are way easier to analyze. So we can talk about this definition.